All right, this time around, we want to look at model interaction and test for shape availability. All right, I mean test for ANOVA or MANOVA, as the case may be, right? So we can actually test our shape availability with our model interaction. Let's look at how model interacts. Let's call it model interaction. Before we do that, don't forget our GDF rather. We need to first convert our GDF to what they call 2D array. So let's see. Because we want to look at the intercept. We want to look at the intercept. You know, we have intercept and we have interactions. Okay. Normal mathematical form of this. We have what we call intercept. We have what they call it now, this other part of it, both intercept and the gradient, rather the gradient, intercept and gradient. But we are not looking at this mathematically now. Just want to look at it basically. Okay, so let's first convert our coordinate to shape to the array now. To do the array, let's call it shape. Let's call it shape. All right, to the array. Let's say 2 dot the array. Our GDF now, dollar coordinates. So the coordinate only, just convert it to, let's see. This will help us run into too many errors. All right. All right. So let's see. Now let's fit 0. Let's look at the intercept. We have LM. You can call LM. That is a linear GDF dollar coordinate. This one you can call this one. Let me see. -1. This is for intercept actually. Let's run this and see. So, summary. Let's summarize this. Summary. Our intercept now. Let's see what we're giving us. All this formula you can have. Okay, let's go. And so let's convert to let's make it a shape now. It's supposed to be shape, not a. Let's make it shape. Shape. This one. Graph. What we have now. You can see it's different from what you had before. How we had before. All right. Different. It's giving us a form of shape now. Different error. Yes, is intercept now. Okay, significant intercept. But that is not where we're going to. I just use that to run to test our residual error. Residual error, standard error is also 0.013 on 59 degree of freedom. So this is giving us a complete report now on the intercept. Let's try and see and do more. Let's say we have a fit now. Fit 1 equals to LM shape. Let's now run it on our log. Let's PDF size now. Right. Let's see what we have. So when we run this, let's do more. Let me first see what we got first. Let's summarize this. Ready? Summary one. What do we have? We have the intercept now. This log size. Intercept size now. Alright. To that error 0.013. 8 degree of freedom. Multiple half square is this. Adjusted half equal to this, and f statistic is equal to this. So this gives value 0.7, not significant. So let's continue. Let's see more. We are trying to run interaction. What to see interaction of our model now. Let's say we have these two. We have LM. Let's say log size now. Log F dollar plus CS size. Let's say plus race. Let's say for process. Let's test for textual dimorphism. Let's test for texture. Let's see if it's effective. If it is let's run this. Let's say summary F2. This test for textual dimorphism actually, right? So we want to test textual dimorphism. Let's see if it is significant. What we have. Can we see ANOVA on that? Let's see ANOVA. Let's see ANOVA on this. Let's see ANOVA. 2. You have. That's not correct. So we can only summarize. So that is you can see that this textual dimorphism is not correct. It's not significant now. Significant on each of the listings. So let's look at the race. Let's see for race. Let's see. That's for population. Let's see. This is population now. Race Asia, Europe, Africa. So we're looking at the race now. What we are having here. For the efficient and for the intercept. Right. So let's go further and see. We're just trying to okay. All right. So now let's look at the test for interaction between sex and log size now. Let's say I want to test. Let's copy this now. For this 3 log size and sex. We're looking at the interaction now. Is going to make it multiply by. It's not a plus now. So what we are doing now, we are test for interaction between sex and log size now. All right. Interaction between them. So let's look at this and run now. So let's summarize this now. Okay, this interaction between sex and error. So that's what we have here. Alright, so you can see that this is just testing for interaction between models now, right? That's what we are doing for testing interaction between the models. So you can do more and improve on this actually. But let's see how do you perform ANOVA then? If you want to look at ANOVA, For example, let's say we have feature 4. For example, now 4. Let's say perform ANOVA now. For example, we have GDF for the coordinate. Okay, we have log. Let's log. We have log GDF now. GDF the central size. Right. So perform ANOVA now. So let's multiply by GDF the race. To use GDF for race anyway. So just race. It's okay. It's okay. Let's just leave it. So we're looking at this. Let's look at the race first. So let's make our iteration. To this $race iteration now. Let's say we have let's make it 999. All right. Now we are going to include our RRPP now equals to 4. Okay. You may have get an error while you run the analysis. Let's run this and see what we have. All right. So it's run. Okay. Let's perform ANOVA on this. ANOVA fit 4 now. So let's run and see what we have. All right. So this is the analysis now. This is ANOVA now testing for shape differences now. Okay. So we have log size. We have race now. This for race and race on size. Testing for race on size. Okay. We have that is significant. All right. This one is not significant. Race on size is not significant, but why race is significant? Right. So you can see this what is called ANOVA here now. Right. So we are looking at the distribution the landmark data in the mean form. All right. So let's test for sexual dimorphism and race differences now. Let's perform one-way ANOVA. One-way ANOVA now. One-way ANOVA. One-way ANOVA. Let's say we have okay. Let's test for sexual dimorphism. All right, so let's say we have fit 5 now. Let's call it fit 5 now. Fit 5. So this is a standard statistic that actually perform on a landmark on differences. Okay, so let's say GDF. Same thing you are still doing nothing much. So on central size now. On central size now. Okay, then we have a GDF GDF plus X. Right, so you can just put X here. Never mind. So it doesn't matter. Then we also have a GDF. Can just put race as well. So it doesn't matter. $race. Right. So on which iteration? Let's say iteration is equal to 999. Right. So here now you don't need to put RFF anymore. So just run this one and see what we got there. So let's try and run this. All right. So let's perform ANOVA on this. ANOVA 5. This is one-way ANOVA now actually. One ANOVA now on the 1999 permutation. That means 1000. All right. So yeah, we have our so the race is significant. It's not really significant anyway. 0.05. It's not less than 0.05. It's not exactly equal to. So we can't consider this exactly significant, even though moderately significant. So some people take it as a significant value, then not significant. So it will be less than. All right. So if it's just ANOVA on sex and race, you can see now sex and race. Sex is not significant, and both race as well. I can't take this one as a significant value. All right. So this is a ANOVA now. Okay. Let's do MANOVA. There's a two-way ANOVA now. Two ways ANOVA or MANOVA. So let's try and see. Let's test for okay. Test for race variation. Let's say test for population or race variation. Race variation in sexual dimorphism. So I want to test for race variation in sexual dimorphism now. All right. So is two-way ANOVA, or you can call it MANOVA as well. That's a multivariate analysis actually we are doing. So let's say fit 6 now. 6 equals to, let's say we have the same method, pro LM GDF dollar central size. Okay, we have also here okay. We have GDF access. You can just put sales. Don't worry. I'm just trying to. So now you can put multiply now. Not this is different now. So this is not plus. They are very, very important. So don't mix it together. When you are performing such analysis, here you must understand that the difference between multiplication and the addition, they're not the same at all. So we are multiplying now because we are looking at a multivariate analysis now. So here I just put a race now. Race. All right, so my iteration, let's make it 999. All right, so you can have this. Let's run and see. We have. Let's perform ANOVA on that now. ANOVA 6. So what do we have? So you can see different from the former one we did before. You can see that it's not the same. All right, so even though the value look the same in terms of result, but the analysis is not exactly the same. Okay. All right. So now we are trying to can we combine them together and see what you have? If we say let's see, we say if these combine, let's combine and see ANOVA. Let's just try this. ANOVA fit 5 fit 6. Okay. So let's combine together. We're trying to look at a multi. We're trying to look at multivariate analysis now. Okay, let's try and see if we combine together two of them and run and see what to get. All right, so we are looking at this result now. Look at what we get here. It's giving us look at the value, giving us a RS. We have P is equal to 0.3. All right, this is Z, this is F value. So this is root square means, and this MS. So we have the value here. This is when they are both combined together now for analysis of variance. So this is a little bit complex analysis, right? So what I try to look at, I try to test now to look at the significant nature of each of those population or races on the sex or sex on races. At the same time, looking at the sexual dimorphisms differently, okay, and they also look at the relation between each of them, how they interact together. So these are the tests you can perform statistically on these ones, okay, in R. Okay, so that is that for now. So you can use the test or the reports generated here now for your analysis. You can see them. So you can use them for both ANOVA and MANOVA, and the interaction of the analysis of each of the components. You can use them. So this one is significant now. You you can report on these ones and document it in your research. All right, so that is that for now. So we are getting climax of the course. So I will see you in the next class. Thank you so much for joining.